All right, so we're dealing with um, a trying to find out whether or not or how to determine whether my line intersects an object or plane uh, or intersects anything for that matter that is drawn on the screen. Um, I've been playing around with ray casting and finally figured out with a little bit of adjusting and tuning for my camera that I have. There's like guides that show you how to raycast, but it's specific to uh, a certain camera that they have set up, and my camera is a little different. Than most cameras. I can go pretty much anywhere with this camera, so I have to adjust for all that, and it was a little bit of a pain to do that, but I found out finally how to do it, and so far, so I have these normal vectors coming out from the center of this object in space. So here are my normal vectors from this object, and um, just so you can visually see them, I made them thicker, and then I drew a function that draws, it uses raycasting and draws a line uh, based on my view direction and my position, or the position of my mouse. So anywhere I put my mouse, it will draw a straight line out into the world, and whatever that intersects, I want to be able to pick that object or determine whether or not that line hit an object in space, and I want to somehow use the normal vectors to determine that. And I think I could do that because I have all these normal vectors calculated already. They're already there. All I have to do is make use of them. And I know that there's a few equations that have the intersection of a plane, a line, intersection of a line on a plane, but you have to have the line equation and the plane equation to determine that. So I'd have to uh, probably write a function or something that gives me the plane or the plane equation for this for every object plane that I create. And it may not always be a plane. It may be just it could be some triangle or something. But it's all in all, it's still plane. It's just not. It's a half a plane, if you will. I think I could still do that, but so this is what I have it. I have this function um, bound to a key. So when I press this function, it'll draw a line from the starting point, which is this point right here, and that's my view direction. So anywhere I'm facing in the world, plus my view direction, plus my um, mouse coordinates, my ray cast. So the view direction is generally in the middle of the screen, and it's always a point. But if I add the ray to it, the coordinates of my mouse uh, in 3D space, then it will adjust for that and move the view direction to the point in which where my mouse is. And then the second point is just my view direction, the same thing, view direction plus that point, but multiplied by 2, so it draws a line out into space. And I'll give you an example here. So I'll want to click anywhere on here, so I'll show you how accurate it is. So I'll click on the corner here. There we go. So it should have drew a line directly, uh, uh, a line straight down from where my mouse is into the world. And let's see if it did that. And it did, but it didn't intersect anything because the line wasn't long enough. So if we move closer, then do it. There. So it should have intersected that point right there, and indeed it did, and it went right through the box and out the other side. And what I have is the normal vector here that I have it connecting to the starting point, and I need to somehow figure out how to work with that. So I know that intersected those two planes, right? So I would need to, more than likely, I'd have to use a plane equation, but I'm just not sure how to implement that. And I'm trying to figure that out. But this ray is actually really cool. I'm glad I got this adjusted perfectly to where I want it, because before it wasn't as accurate as it is now, and that's because I had to adjust for quite a few things. See, that didn't even intersect right there. I suppose, I could use some math functions here, since I have a line calculating that I have a point here, the normal vector, I have a point here, and I have a point here. And now I have, I also have these points, the vertice points, that I could use, which, if I had multiple vertices, I'd have to go through each and every one of them, and I'm trying to find a faster and quicker way to do this rather than jumping through all those vertices in the world to determine whether or not I intersected an object. Because it seems like a waste of calculations if you're doing, say you had like a million objects in your game. You don't want to go through all of those objects. You just want to focus on the one that's, that your line went through. But you do, I'm wondering, like, you can't see, that's like the hard part. Like, how do you do this efficiently? um, you don't want to use, I mean, you could run through every normal vector and draw some lines. That wouldn't be too difficult, but it's still a waste of calculations, because if you have an object, if you clicked here and you're cycling through all your normal vectors and you have a normal vector way out here, you should just ignore that. Like, it shouldn't even, like, there should be a quick calculation that you could come up with, or I could come up with, to determine if I'm close to an object or not. I suppose I could make a function that runs through like world coordinates or something like that, and find out, okay, well, where did I click in the world? Say I clicked here, and that's close to 0, 0, 0, and then I search all my objects, and I could probably make a function that searches only the objects near those coordinates. I mean, that's one way I could do it, rather than, so I can cut out multiple objects. But then I'd have to set the vertex data, because I store the world position. I'd have to cycle through every one of those positions. So what I could probably, I was thinking about like breaking it up into sectors, and whichever sector you enter, it bounds you. It bounds a new array to that sector. So this 10 by, say for instance, this I think it's 20. Yeah, 20. No, is this 20? I think it's 20 by 20. Yeah, so I have 20 by 20. Say this is a sector in the game, and it wouldn't be instanced. It would just be a sector. Breaking your world up into sectors. So this would be, say sector 1, and then I had over here would be sector 2. Now if I go from sector 2 to sector 1, it switches the array to everything that's in the sector. So instead of searching through all sectors in the world, or every single object in the world, I could search in everything in this sector. And I could even break it down to more sectors. instead of just I could break it down to the one sector, which would be one array, and then another sector within this sector. So this sector broken into like fours or something, or fifths. Just break it up into whatever I want. And that might be a more efficient way to search for or to narrow it down, a quicker way to narrow it down to do the calculations quicker. Because I may have, you know, 1,000 objects in this sector, and that's just one sector. So that seems like I could break that down. If I have 1,000 objects in this sector and I broke this down into sectors, it would run it. I maybe have 200 objects within a sector of a sector, and so I could narrow it down to that. So my position is this position, so therefore I could set this sector to this, and then it would only search those sectors, if that makes any sense. I think that would probably be the most efficient way to do this, because eventually I'm going to have more things in this world, and I don't want it to be doing calculations that are unnecessary. Only the calculations that are necessary I want it to be doing. The problem is if you are halfway, I guess, I would have to make it so the object doesn't, I suppose, go into another sector. But even if it did, say if this cube was over here halfway in this sector and halfway in this sector, which sector would you choose? Well, you would probably just choose, the sector in which you're closest to, and I suppose that could work too. That could be a problem. It might not be a problem. I'm not entirely sure. But if an object enters into a sector, like if it's halfway into this and halfway into this one, you should count it into that sector, whether you're in this sector or in this sector. So the object is essentially in both sectors. So I guess that would work still. Yeah, that actually would work quite well. So I could break this into sectors. I think that's the best way to do it. I haven't really seen any guides on how to be efficient with this. It's more like up to the coder to figure that all out. But I'm sure you all have too. Like, what if you were, you were over here in this sector, and you shot, I don't know, say you shot a bullet or an arrow, and it went over to this sector. You'd want to find what, I guess you could follow that object. Yeah, that's probably too advanced right now. I'm probably not going to think about that, but I probably should think about those types of things. Like, what if an object is a moving object and it moves past this sector? Maybe once it enters this sector, I can start searching this sector. If it doesn't hit anything in this sector, if it doesn't, yeah, actually that would work quite well, I think, because if you're tracking an object and you shoot it and it's moving in space, and then you're just searching this sector, it doesn't hit anything, it enters this sector, it's like, oh, okay, new sector, let's start searching this sector, rather than searching like multiple things in the world. You're only tracking around where that object is going in certain sections or sectors. I think that's the most efficient way to do it. So I think I'm going to go ahead and do it that way. But as far as figuring out whether or not I've hit something, these are the kinds of things you got to think about when you're like, creating, I don't want to say an engine, because I'm just kind of messing around with this, but eventually that's something I want to do. And this is kind of the starting point into doing that. So if you don't account for it now, later on down the road, you're gonna bite yourself and have to change a whole bunch of code, and just it gets messy. So you might as well think about that now and fix it or make it, build it up to that, rather than to build something and have to go back and change everything. So it's kind of like thinking ahead a little, quite a bit actually. But yeah, so that's now back to this point. Exactly a point. That's what it is. So we have to, or I have to figure out a way to determine whether or not this line has intersected this an object. So I think that's what I'm going to work on next. I have a lot of ideas. Plane intersection or line plane intersection was one of them. Another one was drawing uh, two planes here for intersection. So I'd have a plane going down the middle, right here, going towards with the x and y, and then a plane going this way towards the z and y. So when you look down at it, it'll look like an X, cross this way and cross this way. And then there's a plane-plane intersection. And I've seen a couple games use that to their advantage, as well as calculating whether or not calculating collision as well. Another another way I could do is use spheres instead of I could use small spheres, but I think spheres are easy to calculate whether or not you've intersected them. It's super easy, and they're all. If I made it uniform, and everything was based on a sphere intersection. The one problem with that is you're not going to hit the if you have a box or something, you're going to move through that box slightly. If you've ever seen games where you're moving and you actually look like you're going into the object, they're using sphere collision detection, which makes things a lot easier. And it's really hardly noticeable in most games that you see. Like you'll move into an object that's not sphere-like, and you'll actually move into that object a little. That's because of your sphere detection, and I think that might be an easier route to go as far as doing calculations in your world. It makes things a lot easier because it's all uniform. You never have to change anything other than where your line is. That's probably the only thing you'll ever have to change. Yeah, so that's what I'm working on right now. I'm trying to figure that out. I'm gonna do a little bit more research on this. I wanted to share what I did here, and essentially, like if you're interested in the code for the ray, there is this website that actually goes through it in quite pretty good detail. If I could find it here. Yeah, here it is. So this site right here, it's Kapinar Ramses or something like that. I'm not entirely sure. It's a guy named Anton Gerdelin, and he talks about raycasting and how to, how it all works. And it's really interesting to look at this and see how raycasting actually works. I would recommend this if you're interested in it. This is like the whole shebang right here, if you will, for 3D space. You got your local space, world space, eye space, homogeneous space, normalized space, and viewport space, and you can go back and forth between any one of these. And it's something that's it's really confusing for some people, but this guy makes it really he makes it pretty. He explains it pretty good. And then he's actually got some examples and some code that you can look at. And you may have to adjust and change a lot of these based on how you set up your world. But essentially, it's the same thing, same concept. You're always going to use this if you're doing raycasting or trying to draw a line in space based on your mouse coordinates. And yeah, I would definitely suggest this. And he's also got, you could also, if you're interested in, uh, more OpenGL stuff, I believe he has a few other things as well. Yeah, he has a lot of explanations on shaders and stuff like that. Yeah, so I'd recommend going over that if you're interested. But that's essentially how I figured out how to raycast based on mouse coordinates. Although I wasn't told how to actually draw that straight line. I had to do a little thinking on my own to determine that, because um, what this essentially does is gives you the ray. It doesn't tell you how to adjust for your ray and what how to cast it in a straight line or at an angle or something like that, something you wanted to do. Although you can do that, but the way I did it, what I wanted was just a straight line. So from wherever my mouse is, I just want a straight line into the space. Because if you were, say, an object over here and you wanted to click on that object, I want to be able to click and boom, determine, well, okay, well, are you far? Do you need to be closer to click on that object? And yes, you do, because this line is not touching anything. So you would have to be closer to that object to interact with it. Yeah, so that's what I'm working on right now. And I think I'm gonna find out how to do this to select an object. That way I can say select this sphere right here, and I could translate it in space. Oh yeah, that's another thing I have here. So the translation based on mouse coordinates as well. And I think I have a piece of code that implements that. And let's see if I can find that here. And properties. So, all right. So all this does is moves it in the world, translates it, and it bases it off the Y. Uh, and or the ray that I created. But there's a couple things that still need a change with this. I'm not entirely, it's not entirely done yet, but this is what it does. So if I was to select an object and I wanted to move it in space, the thing is, when I move it in space, it'll go with my camera, but eventually I'll go past the object, and then I'll have to turn the camera around. But I could still place this anywhere I want. But there's something else that you could do. Instead of going along the Z, see how this is actually moving slowly with me, and if I turn around, it will reset the position, original position of the Z, or whichever wherever I'm pointing, it will go to the max distance. So I could carry it along with me in space, but if I just wanted to move it along the world and account for the terrain, if you will, which later on I'll do, I'll calculate whether collision detection will occur, and then I could calculate that collision detection and adjust the object based on the terrain to move with it, and then snap to like the grid or something like that. But what you could do there, instead of going up the Z, you could or instead of going up the Y, which is my up and down, you could set this to 0.0 f and then set your Z to your Y coordinate. So when you move up in your screen, it'll actually move towards the Z, and the only thing is you won't be able to, the 0.0f is the Y, so you'd have to adjust for that based on your terrain later, based on like normal vectors and collision and everything, right? So this is what it does when you do that. It just moves it. Oh, I have to change it to negative because up is down is up in this one. But it just moves it along the grid itself if you do it this way. It does not move it up and down yet because there is no terrain. But you'd also, again, you'd have to check for collision and then move it up accordingly based on your terrain. But that's pretty cool. You know, you could do that with the ray casting. And let me see here. So yeah, it's not moving that way for some reason. Oh, there we go. It's being really weird because I think it's the negative. Yeah, negative y. Okay, let's see if it adjusts for that. Still didn't adjust for that very well. And I think it's because, like, if I'm moving along, this is the x-axis, and I'm going y. See, up and down would be my my z-axis. So left and right is actually my z-axis, but I'm moving up and down in my y. So if I'm facing the x direction, you know, it's going to move it accordingly left to right based on, you know, because that's the z, which is actually the y, and then my x would be, you know, here's yeah, it seems like that's a pretty, like I said, it's not complete. If you're looking directly down the axes though, like the x, y, and z, it'll work accordingly. But I guess based on your view direction, I'd have to adjust for that, but I don't think it'll be too difficult to adjust for. But that's another thing I'm working on there. But it's pretty cool what you could do with ray casting in general, and it's super effective. And eventually I'm going to have these normal vectors. If you've ever seen a editing software where you can edit an object. Most, you know, Windows has like a 3D builder, and if you've ever messed with an editor, has that. You could select an object, it gives its normal vertices, and you can, you know, scale the object, you could rotate the object, all that stuff. You can move it in 3D space. So this movement may not be necessary, but you know, it's nice to have. So I'm going to work on that and fix that, and eventually it'll work accordingly. Yeah, so that's let's change that back to what it was. And I suppose with this, you know, you have more freedom, and it actually adjusts for, you know, wherever you turn. There's no problem with it. You can move it around, and it's just more freedom to do what you want with this, rather than just going on the grid. But you know, I suppose actually I could change that z to 0 and just add my y. Yeah, I'll mess with that later. But for now, I'm gonna try to figure out that intersection of the line on an object and figure out, you know, if I'm going to divide my world into sectors or not, and how to do that. But yeah, there's an update, so there you go.